So this is video 3, we're talking about voltages. Once again, we'll be working between these tables up here of voltage magnitudes and so forth to this graph down here. So if we remember from before, we were using 13.8 and we had these values here of 79.67. So we have each one of those now entered here at these points right here using VA to neutral as our reference point. So we're kind of looking at this graph like a phase angle meter. So it's going to be followed by V to neutral and VC to neutral right here. So with that, if I were to look at the voltages between these phases, I would have this right here. And here you can see between each one of these phases, I've got a magnitude there that's equal to our phase to ground value right up here. And these are all equal because the magnitudes are all equal and the angles are perfectly 120 degrees apart. If we were to take, say, B phase and we were to reduce B phase by say half, so that's about 8,000. So I'm gonna put 4,000 there. What you're gonna see is you're gonna see that B phase is reduced. So that's this one right here. If we reduce it, and you're gonna see where A phase is gonna end up like right in here, A to B, and then B to C is gonna end up right in here. So we put that 4,000 in there. And you'll see those reduce. So notice that the magnitude for let's see, look at B to C. B to C is now at 10,552, and you'd expect this one over here to look very similar. That's A to B. It's also at 10,552 because all the angles are still the same. All we did was reduce the magnitude. And then ultimately, we didn't do anything with the A or C phase voltages. So C to A is still sitting here at 13,799. So one quick thing, let's just say this angle on this went to, let's just take it to 105. And you can see once again how the voltages are affected. And and you can look at each one of them, and these magnitudes will absolutely bear out to what you're getting right over here on these. So here's A to B is at 10.5, B to C is at 11.6. You see it's a little longer here, and then the C to A is longer than the other two, and it's at 12.641. So all these things have an impact. We'll be applying some of this as we go forward. One other thing, let me put these back to normal. 79.67, 79.67, 79.67, and we got to go back to 120 on this one. Now we're balanced again. We'll turn off the phase to phase. So notice one thing, if I was to measure, how would I get VA to B? Well, first off, I can't just get out there on the bus and do it, but VA to B would be right in here. And if I wanted to measure VA to B against VA to neutral, where would VA to B show up? Well, it would show up right there. Now I'll put that here, that would be at 30 degrees. And if you look, you can make sense out of that. This right here is a 120 degree angle. Each of these is a 30 degree angle. So this right here is in this voltage here is in parallel with this voltage here. Therefore, this angle right here is pointing right to 30 degrees. You can see that. And that's what you'd read on the phase angle meter. We'll do more of that.